0 size. So that's obviously where the bug is, or at least one of the things that is causing us to do horrible memory damage. Not really sure how sample size became 0. It's probably because we haven't decoded anything at this point and SC hasn't been filled out. That's my best guess. Yeah. Hard to say. So let's look at what happens. We're decoding something, and where do we get that SC? That stream context. Stream context. We come down here and we pull out a stream context, which has the data like size and stuff. And at that point, we should have, it should be filled out, right? Import FFmpeg should set that for us. Yeah, and as you can see, it uses it like this. You know what's weirder, though? Ah, no. Can't say that. I don't believe, this is a Audacity structure. This isn't like a AV stream context from FFmpeg, or libav, if you will. Yeah. So what can I say about that? It's invalid here. When we insert it to the cache. By the time we pull it out, it is valid. That's the thing. Because, okay, you see this? We set the sample format here. We don't set a size, we just set the format. So the format looks to be U8, the U8 type, and that could just be that 0 on the thing gets zeroed out, of course. Could check that. Okay, how can we stop the bleeding? So weird that sample size isn't set. M sample size equals. Never happens. I bet I know where it happens. There we go. That happens only after you've decoded the frame. And we haven't decoded a frame here. What we can do, we can say we're always going to use a float here, but you know why that will suck royally. Let's just do it. Get AV bits per sample format. Okay. Something like that, we could use that. I think we should use that. Yeah, we should use that. That's the easiest quick fix. You know what's weird though? The format isn't set until this point, so that means we're using invalid data, which means that we'll be using nonsensical, yeah. This is complicated because the data we write to is relying on this. This is definitely not good. What I'm talking about, let me split this up. If we go down to fill data, where these caches get used later on, we switch on that, on the sample format. And that determines what the output buffer format is in. And we just hard cast like this. So if it's integer type, then if it's a small integer type, we do int, a 16-bit int, and otherwise we use floats. Yeah. So that means somehow at this point we have to know what the correct format should be. Here's a kind of, here's something we might be able to do. So can we see the, yeah, we can see the decode format. So, alright, this is what we do. Look at the decode format. Yeah. This will need some commenting because it's a little messy. But here's what I think will be nice. Alright. So we can't rely on this like that. What we can do is use this format variable. We can do sample size. So, 8-bit and 16-bit audio is not output from FFmpeg means 16-bit int out. 32-bit int float double mean float out. We could just do sample size greater than 2 means float, but yeah, we don't know for sure. I mean, it'll be much better just to write some whatchamacallit. This format will either be float or not float. So float or int16. See here? No, this isn't it. This might be it. We want O-sample format. That's the money one. That's what the wave track will be. So you see here, O-sample format. Yeah, as you can see, the two types are either int16 or float sample. Alright, so we don't use that. Aw, shit. Now, hold on. U8. There we go. So, we'll just keep it nice and simple and have it so we don't have to do any conversion. Like that. And like that. Lots of trailing white space. Lovely. Alright. And that should be what? Float? Is that float? FLT. Yes, those damn vowels. Alright, so now we've got our sample format set. And from this we can determine what the correct amount of bytes for this malloc. So this has to come above the malloc. Yeah. And yeah, because we're doing direct, damn it, I'm not good at talking and coding. Because we're doing this direct no conversion technique, what I mean by that is int16 translates to int16 on the FFmpeg side, and float wave tracks correspond to float output from FFmpeg. We can just use the native sample size. We don't even have to worry about the FFmpeg one because they're the same. So this will pretty much do what we want. Instead of that sample size, we're using the format size. Alright, and now I'm gonna get rid of that. So let's try building and see what happens. So GDB runs debug pretty quickly. It's not like Valgrind. It's tolerable, so, and it'll catch my crashes, so I'm happy to use it. Alright, so now we should no longer see those U8 debug messages. They should all now be U16 or F. I'm surprised that those are float. Yeah, I'm very surprised. Did not expect those to be float. So crash probably happened in the same place. Yep, copy samples, apply. I want to just run with Valgrind again. I just want to see if we're getting some new errors. Before we were mallocing size 0, which is never good. I want to make sure that those have moved away. Or maybe something we're doing is not handling that. I don't know. This will be a good way to check those assumptions. As you can see, just starting up takes a very long time. Okay, don't recover. Come on. Alright, so I'm gonna open up this guy again. You can even see the import happen. Alright, there was a bunch of stuff. That looks okay. That's just the track artist stuff. There's lots of weird stuff, but here's the crash. Alright, so that first read is still invalid.